So I hope you can all see that there. I'm Jonathan Morgan. I'm the CTO at Autogrow. I kind of like to just talk a little bit about my background and kind of how I ended up here, and what's kind of changed over the last number of years. So I've been in IoT for about 7 or 8 years now. I've worked across multiple different verticals, whether it be telematics devices with eRoads Gen 2, releasing that to market. There's about 50 to 70,000 of those out on the field right now. Working with NZTA on their Weigh Right project, which was designed to weigh vehicles as they drive down the road. So think trucks driving 100 kilometers an hour, weighing each axle, finding out whether that truck needs to pull over or not. Moving on to low-cost asset tracking, again back at eRoad. And then finally moving into AgriTech. And what I've noticed is over the last kind of 7 or 8 years, things have changed quite considerably. And when I first got into IoT, the common question was, can we do it? Is it technically possible? And Rachel did talk about the laws of physics, and I would say that definitely does come into it. But over the last 7 or 8 years, this has become significantly easier. And when it comes down to it, it's the increase of technologies that are out there and the increase of people that are actually playing in this space. Whether it is the release of Bluetooth 5, narrowband IoT, the LTE network's been available. 7 years ago, everyone kind of had heard of LoRa, but it wasn't a common technology that was used. Now there's hundreds of different devices that you can use for enabling you to basically connect with LoRa to something else. And finally, batteries actually improved. You can probably thank the connected car market or electric cars for doing it. Like over the last 20 years, the quality of the batteries and the lifespan you can get out of batteries is really different. And so it's kind of gone from the space of can we do it to yes, we can do it, but we can do it basically at a cost or at a time frame. I no longer think of any manual task that is happening on a farm or in the industry as being a manual person going out and measuring something. That can always be replaced with IoT. And the question is, how fast can you do it and whether you can get it at the right price point for your customer. And so with that in mind, I'm just going to talk about some of the slightly more out there examples that I've seen. And on the left here, you've got Aruga AI. And for you guys that don't know, bumblebees are actually illegal in Australia. And so when they talk about pollinating in a greenhouse situation, and so what you see here is an Australian greenhouse growing tomatoes, they actually have people doing it. So if you want to picture it, think of someone either with a Philips Sonic toothbrush, basically going up to a tomato plant and watching it vibrate to essentially shake loose the pollen. And when you talk to growers, labor is the #1 problem that they always talk about. It's their #1 cost. It's the biggest hassle. And so what these guys basically did is they produced a robot that goes down the greenhouse. It uses cameras. It targets a flower and it shoots air at it at a higher pulsating rate. And at the same time, it's taking all this data of tracking of what is happening to that flower, how that flower or how many flowers are at a certain state, and feeding that back into their systems. And so it's kind of one of those out there examples of how you can actually make a massive improvement. It's interesting that when I was talking to the guys about it, they're actually more accurate or better at pollinating than bees, because of the technology that they're using and the ability to apply that technology. On the right there, you've got Halter. Now, Rachel talked about it a little bit earlier, and if I look at 7 years ago, when if someone had come up to me and said, can you remotely control a cow? Now, I would have said no. Now, Craig in the picture here obviously said yes and started down this path of making use of these technologies to enable him to do that. And that definition of the Fitbit for cows is actually 100% accurate. Now, there's a lot of work that goes into that. I have been into Halter a number of times, and they have actually a team of people sitting there training their algorithms based upon video images of cows and associating with the data they're getting back for the collars. And so if you think about it, it's someone sitting there going, the cow is sitting, the cow is sitting, the cow is sitting, he's now standing, he's now eating. And it takes a lot of effort to do that, but it is possible. And that data, in the coming years will be amazing for these farmers who are able to then build their platforms on top of it or build functionality and solve problems on top of that. So what have we been working on? Well, this year we've released our Folium sensor. And really our goal behind Folium was to increase that data density for growers. And I was talking to a consultant the other day, and he said, well, 20 years ago, microclimate was your farm. And then, we started to get more into controlled environment, and microclimate became your greenhouse. And as far as they're concerned now, microclimate is now your plant. They want to know what is happening to a plant. Now, to achieve that, you've got to basically get data density at the right price point so that you can actually track what's happening, at the plant level. So we released Folium, which has got 6 sensors in one. And we solved a lot of problems along the way with that sensor. And one of them was range. And I know Rachel's presentation had Bluetooth in the top corner, and I think it was around about the 10-meter range, going up to maybe 100 meters. Our sensors get 1.5 Ks in direct line of sight. Now, direct line of sight is pretty unreasonable. We had to go test it at a beach. There's not many places. If you've got your own private airport, you could maybe go test 1.5 Ks direct line of sight. But to give you an idea of a real example, we've got a blueberry grower up north. They're getting about 560 odd meters through foliage, getting the data back from those plants and feeding it back into our gateway. The other thing which we solved is, working out how we could actually make use of the battery power that we've got to make it more easier for the growers. I was in a grower a couple of weeks ago, and we were talking to them, and they happen to have wireless sensors, and they were like, oh, we've got wireless sensors. And we're like, oh, okay, how long does the battery last? And they said, oh, yeah, we get about 10 days, and we send someone out, and then they swap out the battery, and they take the data recording away, and then pull it back. And we're like, oh, okay. And how long would you want it to last? And the statement from the grower was, well, it'd be great if it could last 30 days. That would make 1/3 of my labor impact. Now, our sensors last for about a year out in the field. And depending on what sensors you got plugged into it in the bottom, you can actually even last for even longer with it. Now, how did we kind of achieve that? Now, we achieved it by focusing on what we're good at. We happen to have a hardware team. We understand a lot about agriculture. We didn't build the specific sensors itself, but we combined the sensors into a unit that meets our customers' requirements. If I go from left to right, we then use a gateway, which we describe as our IntelliLink, and it's running Amazon's IoT Greengrass to enable us to handle the connection details and do the store and forward if the connection goes down, drastically reducing the amount of bugs and the effort that we actually have to do around it. It then goes up into our AWS platform, or our IntelliGrow platform, where we're using IoT Core, a lot of the IoT rules, step functions, DynamoDB, and hopefully we'll start moving towards using the time series database or time stream from AWS. And we take a serverless first approach, and we kind of do that on purpose. And the reason why we do that is it saves us time. We don't want to be solving scalability issues and other things like that. We're focusing on what we're good at, which is the hardware on one side, and then on the other side, we've got our SaaS platform. So we're building out the specific functionality that our growers require. And for us, that's heat maps, graphing, alerting, and the other things that's required for the grower to enable them to do their job. Now, the technology and the data is actually an important thing, but really what's the impact of that? And one of the first customers that we actually rolled out to was a grower that had no sensors at all. They had people walking around manually checking what was happening in their greenhouses. And for them, this was a kind of a whole new concept of we could actually record back all the data in real time. And during the initial trial, we actually had our field trial specialists looking at the data, and they said, oh, it looks like you guys are going to get botrytis. So looking at the humidity that was happening in the greenhouse, and they contacted the grower and said to the grower, hey, look, you need to change your environment. You've got heaters there. You've got other options. You need to do something around this. The grower kind of went, oh, this is kind of normal this year. Nothing really happens. And then 2-3 days later, they'd lost about 50% of their crop. Now for this grower, they weren't a huge grower. They were about a minimum-sized grower, so it's about $20,000 worth of crop loss in that greenhouse. I think if you do the multiplications up to, say, a hectare greenhouse, it was around about the $50,000 to $80,000 of crop that they would have lost. And also the other impact of it is that actually once those plants died, this was the middle of winter. They couldn't then regrow this. They didn't have the right conditions to essentially start off. Anyone who works in horticulture will understand that actually plants take time. You can't actually rush them to stage X. There's no instant thing to grow something to a point. We've got growers actually up in the Netherlands, and what they're really looking to do is understand their key costs. So labor is generally number one when you're talking about controlled environment agriculture, and number two is always energy. And so one of the biggest parts of energy is CO2. So we've got growers now that have put foliums, the 4 of them vertically up into their greenhouse. And essentially what they're trying to do is monitor how the plant absorbs CO2 or how it breathes in the CO2. So they've got one at the bottom, and if you know anything about CO2, CO2 drops down. It's not really ideal because you've got light coming down from the top and you want the two to be in balance. But at the bottom, they expect CO2 to be the lowest or the highest reading. At about the mid plant of the tomato plant, they're expecting a reasonable amount of CO2, but it's starting to drop from the bottom part. And then at the very tip of the plant, they want it to be just above ambient. And above the plant, they want it to be completely at ambient. So the scroller basically set this up and used it to monitor for a number of months to actually understand how their dosing was going. So, they had one CO2 sensor across their whole farm, and they had no idea really actually how CO2 was being applied. And so when they were dosing, the CO2 at the top was always above ambient. So they were essentially A, polluting the environment by releasing CO2. B, they were wasting a core cost. CO2 is a very expensive thing. They're burning gas to do it. And so by monitoring and actually looking at what was happening in that environment at a more micro level, they could then save costs, moving forward. And finally, I'd like to talk a little bit about Farm Road. Now, in controlled environment agriculture, I found it really funny, actually, Rachel talked about, this thing of, smart greenhouses. Smart greenhouses for us have been around for a while, and it's been great because we've got this data historically. So our first connected controls are about 7 to 10 years old, and we've been pulling back that data for a number of years. Now we've got that history of data, and that enables us to start doing things and solving problems for growers in ways that we wouldn't have previously. And so inside of our Farm Road platform, we have yield prediction. And why does yield prediction matter? Well, it takes all that environment data, a bit of the practice data, and our knowledge of how plants grow, and we combine it together to predict what your yield will be 1 to 6 weeks out. And we've got a grower up in British Columbia, and they actually lost 3 customers last year. So they grow an organic tomato, and they cannot go out to the open market to supply their customers if they don't manage to grow the tomato at the correct volumes. And so last year, what actually happened to them is because they didn't do any yield prediction, they couldn't predict what their yield was, they actually lost 3 supermarkets that no longer stock their products. Because what ended up happening was they were unable to supply what they had promised that they were going to supply to the supermarket. The supermarket had empty shelves. And so essentially the supermarket had to make a decision of, do I want empty shelves or do I need to move on to another supplier? And they chose to move on to a supplier. Now, if you're any business, losing your access to market is a major impact, especially when you're talking about a high value crop, which is organic tomatoes. And we've done business cases with one of our head growers who works in this industry, and he looked at it from the example of, say, a 20-hectare farm. So a 20-hectare farm, if they were able to accurately predict the yield, they would be able to make an additional $1.2 million US through no additional work, but actually just providing sales with the accurate figures so that they can sell the right product at the right time. They can start to do deals with supermarket to clear excess supply, or when they're actually going to get a reduction of supply, they can make sure that their fill orders or their orders are actually at a low amount so they maintain a high fill rate. If you don't have that fill rate, you're either going to lose the supermarket, or the supermarket's going to reduce the amount that they order from you in the future. So I guess lessons I've learned over the last 7, 8 years. It's been quite a long time, actually. Now, probably the biggest one is we no longer have to worry about the technology problems as much. I'm quite confident generally with any problem I can work out a way of solving it. But the main thing to think about is the customer is key. You have to solve their problem and you have to get the usability correct. IoT is actually quite complicated because you have this very long chain of things that need to work together. So you need to make sure you got the installation right. You need to make sure you've got the battery life, the usability of the product, as easy as possible. And we always talk about consumer grade. No one gets trained on Facebook or LinkedIn. And ideally, your IoT products need to be similar to that. Your onboarding process needs to be really easy. The ability for them to roll out, and you don't want to cost them labor with having to go to those units for servicing or other things. And so that's one of the key things that you kind of need to get right. The other part is recognize what you're good at and what you're not, and then find partners to kind of fill those gaps. We chose to work with AWS on the platform, and that's because I don't want my developers solving scalability issues. There's a lot of stuff that we need to solve ourselves. We need to solve the business problems for our customer and the technical problems that are specific for us. A lot of this generalized stuff doesn't need to be there. And if you look at it, inside of New Zealand, there's also a lot of people you can partner with. if there's another company that's actually producing a similar type of sensor, that you can work with to apply it to your problem or your area. Or maybe you're a hardware provider and actually, you're looking to get your hardware into the cloud. Look at what opportunities there are out there. We're kind of really lucky because, inside of controlled environment agriculture, New Zealand's not big enough. And so I kind of encourage all New Zealand companies to actually look outside. We have to sell globally because actually New Zealand doesn't have a market. If we were in orchard crops, we might be in a slightly different situation. But a lot of the technologies you're looking at, they're quite expensive to build out. But if you look at the global market, there's a huge opportunity in this space. And the final point is really just kind of overcoming your mindset. A lot of people kind of have this negative view of, oh, this is going to be really hard. And honestly, it's not easy, but it definitely is possible. And with all these things, you just kind of have to look about, how quickly can you get it to market, or how much it's going to cost you to get it to market. And once you get those right with your customer problem, you're normally on to the winning solution. And so that's all for my presentation today, and I'll hand back over to Rachel.
Great. Thank you so much, Jonathan. Sorry, I can't seem to, there we go. Hopefully you can see me now. Okay, so that was a great presentation from AutoGrow. So what's next? You've heard all this interesting information. Hopefully you learned a little bit. Hopefully you're excited about IoT and you want to know how to get started. Well, first of all, reach out to us, talk to us, let us know. We have an alias you can use, agteam@amazon.com. So pretty simple. Or even better, talk to us today or tomorrow, or I believe even Wednesday. We are having one-on-one sessions. So if you're interested in chatting with us about a specific use case, or you want to dive into one of the features or stories you heard today, feel free to schedule a one-on-one with us as we're available. I believe we still have some open slots. Now let's move on to another customer that's going to talk about what they're doing in agriculture with their own IoT solution. So with that, I'm going to hand it over to CropX. I believe Eitan and was it Bridget? Are you there?
Yeah. Yes, we are.
Yes. Perfect. I'll hand it over to you.
Thank you. Hi, I'm Eitan. I'm the General Manager of CropX New Zealand. Bridget, if you can introduce yourself, I will.
Yeah. So I'm Bridget Hawkins. I'm now the Chief Sustainability Officer for CropX New Zealand, and up until very recently was the CEO of Regen, and Regen was acquired by CropX just a couple of months ago. So Eitan and I are now pooling our resources and that of CropX and Regen to deliver even more services to farmers here in New Zealand and across the world.
Yes, so thank you, Bridget, and we'll talk again quite soon. Happy, thanks AWS for having us here. I will try in the given time that we have to tell a little bit about CropX, about the adventure that we had to go through in the IoT world, and the specific agriculture area where we're at. So a few words about me. Generally, I actually coming from the technology, from IoT, mainly in the security area, like tens of years experience in the world of security. And then like about 5 years ago, I moved into the agronomy, which brought me to CropX. And let's say just after 1 week at this company, I started looking differently at the potatoes that I eat. And you know, something that you do so seamlessly, you suddenly understand how much knowledge is behind everything that we are eating and growing. So this is where CropX started, actually with an idea in New Zealand, saying that maybe if we'll be able to measure correctly the soil moisture level and temperature, maybe we can influence the way we irrigate the soil. And based on that research, CropX established in 2015. And what actually the company does is the world's leading in-soil analytic platform. So the beginning was just understanding the connection between soil moisture and temperature and other measurements to be able to do more with less. And actually, the whole story behind CropX is that we were never trying to be like a sensor company or a hardware company. We are much more of a solution. And then the let's say the founders sat together and asked ourselves, how can we be number one? And what are the barriers in agriculture? And these are the some of the points. Later on I will more elaborate about that. But there is a big issue with scalability. It appears that mainly in the farming area, it's a very seasonal sector. So everybody are very busy at the same time of the year and doing nothing also at the same time of year. So it's quite hard to support such a market if you don't use the force that is very busy anyway, which are the farmers themselves. So we looked for a do-it-yourself solution. And I'm so happy to say, I'm sad about COVID, but I'm happy to say that COVID didn't stop us, because we didn't need any agents or service supplier to go and support our customers around the world. We just continue sending and shipping our goods to the customers. So the technology itself is something that couldn't be established without the capabilities that was just presented by Rachel. And I will just jump quickly. I don't want to be over technical, but and on the other hand, not over agronomical. And I'm not an agronomist. This is where Bridget probably will be much better than I am. But we try to understand why the sector is not delivering in some of the issues, and where were the lack of the ability of getting better results. When we started, like when I went to farms like 5 years ago, I went to the farmers and asked them, how do you irrigate? And they said, like my father. And how did your father? Like my father's father. But this cannot continue anymore because of stress in the, let's say, the cost sensitives. And the second issue was the issue of environment protection. All those issues forced everybody to start looking how to do better with less. And most of the farmers and the solutions that were available 5 years ago usually looked too late at things without a real predictive value when you look at your plant after it is, let's say, if it was over irrigated, or if on the other hand, let's say, was stressed. So when we started asking where we'll get the most valuable information with regards to the irrigation, we looked at the soil moisture. And this is how we decided that it's very important to develop something that we couldn't find in the market at that time. Something easy to use, which you don't need like 2 days of installation. You don't need the calibration. You want something to be able to scale quickly. This is how actually eventually we decided on going and establishing our own sensor after we did the market research and we didn't find anything else. And then we said we will give an actionable insights to the growers, which contains a lot of knowledge behind that, but eventually it will give a simple direction to the farmer. Irrigate, don't irrigate, do it here or there. And later on I will even elaborate how we can even go and do what we call variable irrigation. You don't need to irrigate everything at the same level. So this is the next step that we took. Eventually, we wanted to develop, and this is what we've developed, something which is always connected. And when you talk about IoT, you start with connectivity. That's the biggest issue. I mean, just like Rebecca mentioned, you can't have an IoT or an internet without being connected, and that's a real issue when it comes to agricultures and remote areas. And this is where we found few ways to do that. I will later on elaborate on that one. The second is to be able to be scalable and to do it on a seasonal basis. So I can't allow myself holding hundreds of employees to do installation for only 3 months a year. We needed to find a way to utilize the farmers' capabilities to do it. And the third point, and this is very important, this is something that nobody should be confused about. The farmers, at least the farmers that we've worked so far, mainly in the US market, are very sensitive to cost. And just recently I saw it also in New Zealand, where we just started our activity over there. Regen is there for 10 years, but CropX is now just establishing their first steps in establishing a local presence in New Zealand. If you are not affordable, you will not be taken. That is something that is very important, and this is why it's very important to select a solution when you need to have a scalable solution, like a cloud service, like Amazon in this case, where it is scalable and you can operate it cost effectively by seasonality as well. This is very important when you are holding mega data and processors. I'm not going to deep dive into how you do it in Amazon. You have the team over there to do it, but this is something that was very important, that you will have something that is scalable and you can take down services that you don't need during a different time of the year. And the last but not least, the biggest issue we found during our research is that we couldn't find real accurate sensors. It appears that measuring soil moistures is very complex, almost impossible if you don't do it very, very uniquely. And we found a way with a lot of data points and a very unique patent solution that was invented to allow us getting a very high accuracy measurements on one hand, on the other hand, with not too expensive equipment. So how does it look like? I'm warning you, next slide is going to be a little more complex. But what do we have? We have the sensor, we have the cloud, okay? And our sensor brings the soil moisture sensor, the temperature, and what we call EC, electrical conductivity. With those 3 measurements, which we are doing in 2 points, actually, we can then estimate using AI an endless number of points in the soil between the sensors and also below the sensor, just by doing right calculations. So we have a very good detail coming out from the soil, but that's not enough. We are taking under consideration in our calculation and the ability to recommend something to our farmers is that we need to use the topography. We need to have a very strong agronomical background to know the crop models. It's not that corn grows exactly like potatoes. These are totally different things and different way to deal with. Weather data is very important and it needs to be precise. We are always looking at the performance of our weather providers, and so far they are quite well. We also use an imaging, satellite imaging. There are companies that based their whole solution only on satellite imaging for recommendation to the farmers, but this is very problematic, probably for New Zealand specifically. I unfortunately haven't been there yet. I'm going to be there by year end. But I heard the name of this island is the White Cloud. So this does not do much well for satellite imagery, but if it combines more information, it can help. And also very important information that we take from the grower. We are asking him a few questions about his field, about his irrigation solutions. Doing that, adding that to the cloud, helps us also give eventually the right recommendation. And I will jump to the last, if you can see here, the view that you see here, this is a view of a pivot where we are recommending the farmer to irrigate differently in each part of the field, although it's the same crop in some cases, or if you have few crops, it goes again. And most of the farmers today, unfortunately, don't do that. Most of the farmers just irrigate equally for the whole field, and everybody knows it. Anyone that you'll ask will tell you, no, that's not right, but this is how we do it. It's easier, it's simple, and it's probably will not cost me anything to do it that way. Now it's changing. It's changing because water become a very important resource. And the second issue is pollution as well. And the environmental conditions brought us to very great height in using that. So just before I'm moving and give this information, moving to Bridget, what we've managed to occur in the recent, let's say, active 3 years, we are active commercially. Before that, we mainly did the research and development, is that we have right now about 4 million acres monitored on the same cloud. We have 5 million daily data points going through our sensors to our cloud. We have 5,000 years of crop data. If you accumulate all the data that we've collected, including asking the farmer at the end of the season, how was it? And then we can learn what we did good and less. And 100,000 growers' data inputs. So these are the things that made us unique in this market. I don't think anyone yet did that. And this is very important for me to share with you, that the way to do or to decide on your platform is starting with looking 10 years ahead. Because if we would start like we started with 100 sensors, probably we never thought of going to a cloud or IoT cloud and things like that. But this is not the way we looked at things. So Bridget, with your permission, I will mute and go ahead, please.
We just, yeah. So as Eitan said, Regen started over 10 years ago, and we had an IoT solution right from the beginning, not that anyone called it that, but the concept of taking data from a farm, taking it up into a cloud, doing some analysis and providing a recommendation, some insight, is what was the foundation of Regen's business. And over the years, what we have learnt though is, although IoT is incredibly important and really is one of the big platforms that's enabled these types of services to develop and expand, is that for our customers, they still don't actually know what it means. And so it's really important we never talk about having an IoT solution because they're not 100% sure what it is, and they're pretty certain they didn't need one of those. And then secondly is they don't realize how transformational IoT actually already is to their farming business. So an example here, this is one of our customers, an irrigator down in Canterbury. There's 18 separate data sources that from that farm are, and 2 different external data sources to that farm that are sending data in every day that we're using and combining to provide them with recommendations around irrigation. So just for that single farm, that's over 2,000 data points every single day that get brought together through IoT connectivity, our platform, the algorithms that underpin it, to give to them what appears to them something really simple to do that, enable them to actually utilize those 2,000 data points. But the other thing is in New Zealand, most dairy sheds, which I realise I spelled wrong, dairy sheds have significant amounts of automation within them. Most, they'll have automatic drafting that goes through into their animal management system. They've got stuff collecting around animal health, milk quality, milk temperature. So there's about several thousand more data points coming up from that place. They'll have lots of bits of farm equipment. A lot of that these days also has IoT connectivity in it. Whenever they apply fertilizer, that'll all be tracked and added in when they do stuff around the effluent management. And so for what is a pretty standard farm, they're deeply embedded in an IoT world, but for them as the actual ultimate user of it, it's not visible. And that's, I think, where platforms and standardization are really vital. If a guy's out there, he's got cows to milk, brakes to move, fertilizer to apply, staff to manage, wading through tens of thousands of data points themselves to work out what to do and how these different activities interlink is not something they're ever going to do. And so for us in the industry, being able to actually pull these things together and create the insights that are meaningful, that allow them to do things differently, that allow them to make sense of it all, is what's required to sort of enable the power of the technology that IoT and platforms such as AWS actually enable. And, as I said at the start, that's what Regen's purpose was right at the start, and now partnered with CropX. We're really looking to carry on that journey of taking all these different things that are now developing all the time, but keeping it simple and straightforward and making it easier for our customers to do a better job along the way. Thank you, Eitan.
Thank you, Bridget. So what I wanted to share is, I needed to think at a given time what would be interesting, others that would like to think of going into to an IoT world. So I decided to take the sensor and the process that we've been through in the last 5 to 6 years. So I will say it only in one phrase, that we've always improved our digital agronomist capabilities. Actually, we are moving towards almost autonomous irrigation, okay? And to do that, we need so much information, but this is where we're at. And we are very, very proud in what we've managed to achieve agronomically with our sensors and external data that we are accumulating into it. But going back to the technology, I want to share with you what was the technology process that passed through CropX. As I mentioned, we can say that commercially we started somewhere in 2018, but before that we had like small trials and beta, mainly in US. This is where we started. This was the first market. So in 2015, our sensor actually sent SMS text messages to a cell phone that we had in our office connected to a laptop. So that was the, let's say, the first IoT, and these were the first sensors where we needed, I don't think we had the solutions of Amazon at that time, but we needed to look for something. So we took off-the-shelf hardware that can easily be, let's say, set up for doing those text messages. And this was quite a journey, but it really was the first time that we showed farmers that we can bring their data from the farm to their office or to the cloud. Because before that, they needed, and most of the farmers are still doing that, sending people to look at what we call tensiometers in order to see the level of moisture. They can do it few times a week, and in some cases, most of the time they're just driving to the fields. In 2016, we moved to a server of text messages, not our own, and this is where we first been introduced to an IoT cloud. I think we were one of the first customers of Opcom at that time that started selling this solution. And we started designing our own hardware. I'm not talking about the agronomist part. This was always under development and improvement. I'm talking about mainly the connectivity and data link part. So this is where we made a major jump into IoT, and we already had, like, I don't know, about 500 sensors out there under trial. And then we moved to data. We moved to 3G. By the way, we discovered it was, again, mainly in US, that in some cases where we couldn't send data, we were still able to send text messages. So we used those text messages as a backup to send the information in case data is not moving. And we developed a whole new hardware and firmware, because this is where we started understanding the part of energy, or the importance of flow energy and management of energy. And we couldn't use out-of-the-box solutions. Nobody really thought of that part, what we needed. In 2019, and this is where we've established our new design of electronics, we introduced to the market a new electrical board that includes almost any connectivity you can think of: 3G, 4G, Cat M1, which is actually based or made for IoT. Very happy to say that we've just tested it in New Zealand. It works fine. New Zealand is covered quite well for this technology. And then we also started talking to our sensor, including an update of the brain inside the sensor, the firmware. So FW over the air, firmware over the air, that's what it stands for. And we've also introduced to some of our customers, by their request, a satellite solution, satellite connectivity solution. We don't think it is scalable due to still the current relatively high costs of data moving through satellite solutions. So we don't know where it goes with that, but we still have that solution. And eventually, today, if you buy our sensor, which is the latest version, you will find inside the sensor a LoRaWAN capability, a Bluetooth or a BLE to allow us also download and talk to the sensor in remote areas where you have no connectivity. Just be next to it and it will download to your cell phone until you'll be in an area with connection. You can take the data. And we still believe that LoRaWAN, hopefully, not believe, we hope, okay, because we put LoRaWAN in all of our sensors, will be probably a very good solution for the agriculture technology. And this will help us covering all the rest of the places, the remote places with no connectivity. We've actually reestablished our IoT cloud, a lot with the help of Amazon, our AWS. And last but not least, we are now having a very strong API and connectivity to other services. And the just recent version that we've issued a couple of weeks ago, we have been connecting our system directly to the third of the size of the irrigation system provider named Rainki. So farmer can actually send the irrigation recommendation directly to the irrigation system without even, it doesn't even need to look at the data. Everything is done and processed by our system. So to tell you this is 100% accurate, no. But is it more accurate than what the farmer would do? Yes, definitely yes. Much more accurate and much more good to the environment as well, and will bring, and these are some of the results that I will show you later on, will bring much better performance. All this in a very relatively low price and low cost for the farmers. So what can I show here? So the graph that you see here, this is not the COVID. We usually, everybody looks at COVID right now in graphs, but this is our sensor spread in the recent years. So in 2018, this is where we actually started commercializing our systems. We sold about 1,000 sensors, about 1,500. And then in 19, we've passed the 2,500. And in 2020, we are already above 8,000 sensors out there. And we do hope, and we are on our way, and this is where we're preparing ourselves to double ourselves for 2021 with additional more data points. And what you see here, these are all places where we have our sensor installed and operational. Also in New Zealand, we just started our, our implementation, and I think that by next year we're going to have like hundreds of sensors all over New Zealand, part of this cloud. So what does it do? Eventually, we proved agronomically that we can save 40% of the water and increase 10% of the yield. And we have like few very long experiments that we did in order to do that. I think I've left 4 minutes, right? So I'm going to try to utilize it as best as possible. What it is used for? It is used for water conservation. It's very important. Leaching or runoff. This is also something that regulators strongly start pushing for regulations which will force farmers to prove their capability to measure what they are doing. And I will not go through all the different sectors where we are aiming to, but actually we know that going into VRI, variable rate irrigation, is something that will allow a very important usage or better utilization of the resource named water, which in some places is very expensive, not only financially. So what are the commercial highlights? After all, we are a company. So in Q3, we did a successful Series B, and we have like a few leading managers or executives joining us. John Bickerpitz, which was one of the highest executives of Netafim in US, joined CropX. We've partnered with Farm Agro. I will jump to the acquisition of Crop Metrics, a great step that we did in US, which helped us radically increase the number of sensors and presence in US. And I will jump to Q3. On September, we've just acquired Region. Very happy from that. This is how actually Bridget and I started working together. Region has a very, very strong base of customers. Maybe I'll jump to the next slide. And this is something very important for any SaaS provider or IoT, which also goes with the SaaS, is that the retention level is very high, and this means a lot. So 10 years experience, 99% retention of its customers. This is very impressive for Region, and it's in a very strong foothold. And this also brought us to additional new sector of effluent, which we never been an actor or players. And now that we are learning this, probably quite soon we will combine it in our system and increase dramatically our offering, not only in New Zealand. The effluent is also globally needed in many other places. So these are the management, and I think I do need to say one word about our, let's say, who's funding our salaries and our activity. We are still not balanced, but we are quite close to that. but we have a very strong venture capitals behind us in the area of AgriTech, in the area of big data, and also some family offices. The second part is our strategic investors, like Renki, which is an irrigation system provider, or FarmAgro from the agriculture, or ICL, a huge company in Israel for fertilizer. Flextronics also invested in CropX, and Bosch, looking at the edge of sensing. So more or less, we are strongly backed with those funds and players, and we're here to stay. Probably increasing our presence and the IoT, and probably also the usage of AWS solutions. So thank you. Those slides will be available. I will send it as a PDF or whatever the organizer will say. This was my part. Of course, if there were any questions, I didn't see it yet, but I will be happy to answer.
Great, thank you, Eitan, for a great presentation. Thank you, Bridget. And also thank you, Rachel and Jonathan, for earlier on today. So that's the end of today's session. Please stay tuned, of course, for tomorrow's session. They'll be kicking off at 11 o'clock New Zealand time, 9 o'clock for some of you guys in Australia, depending exactly where you're based. Tomorrow is going to focus on computer vision in AgriTech and look at some examples there. Thanks again to the AWS team for putting all this together for us, and for the Oz AgriTech team for sharing and bringing people to the event. At AgriTech New Zealand, we do have several events coming up in the next while, so we're continuing this series over the next couple of days. We have a webinar next week on the investment scene in global agri-tech, which should be really interesting with the team from Finisterre. And we do have in New Zealand, in Auckland and Christchurch, some networking opportunities with some updates on progress in the agri-tech industry transformation work. So hopefully you guys will see some invites coming out for that. We look forward to seeing as many of you as possible at those sessions. I'll just drop a couple of links into the chat for some of those events coming up. I do want to mention as well, as we're talking about innovations in the sector and looking at what's happening. Of course, we have field days happening next year in a physical fashion again, we hope, and I'm sure will happen. Will also be online. And so the Field Days Innovation Awards are something to start thinking about. And so we'll show a link very shortly, but please look at the Field Days site and start thinking about those innovation awards so we can start celebrating all our successes as we have been today. I think that wraps it up for today. Thanks for dialing in, and we hope to see you all again tomorrow and at future sessions. So thank you all.
Thank you.
And here are the details on the Field Days Innovation sessions. Thanks to all our presenters today. Have a good day, guys.